Okay, this is 9.1, area of parallelograms and triangles. So you probably already know the equation for area of a parallelogram. It's just base times height. We've probably heard length times width, but we're going to stick with base times height. All right, you probably already know that we need to label area as units squared. Okay, so let's look at why that is the case. All right, so if we draw a pretty simple parallelogram, let's go ahead and draw a rectangle here. So this rectangle is 4 by 2. And let's say these are in inches. Okay, so this is 4 inches and 2 inches. All right, so as you can see here, it's pretty obvious when we have a figure drawn on a grid like this that the area, which would be base times height, which would be 2 times 4 is 8, is made up of 8 1 by 1 squares. Okay, if you draw that out, it seems pretty clear. You have 1, 2, 3, 4, 5, 6, 7, 8 squares. And that is why we label area as units squared. So this would be 8 inches squared. Okay, but you're not just going to see rectangles and squares. You're also going to see some parallelograms that have some slanted sides like this. Try to do my best to draw this on here. All right, there we go. So what's important to recognize is that this side here is not the height. So if they give you a value here, that's not the height. The height will either be given to you off to the side here with some dashed lines, okay? That would be the height, or you'll see it on the inside here as a dashed line, okay? So just to keep that straight. All right, so let's look at some examples here. All right, the first one, let's just do a nice easy one. Let's draw another rectangle. Let's say we have this side, that's a really bad rectangle. Let's say this side is 4.2 meters and this is 6.3 meters. Base times height, all we have to do, type this into your calculator, multiply it out if you want to. This is 26.46 meters squared. Okay? All right, this is an example of what I was just talking about up here. So this value here is not our height. This one here is. So that's really all you have to do, all you have to recognize with this one. So we're going to do 11 times 7.9 and we get 86.9 yards squared. Again, very important that you write squared, otherwise the answer is not correct. All right, this next one here, this one's a little bit different. We're given the area, we're given the height, we're not given the base. Okay, so what I would do here is I'm going to write out the formula. Area is equal to base times height. All right, now we're given the height and we're given the area, so I'm just going to substitute out those numbers. So I have 12 is equal to 2 times b. All right, and then I just need to isolate b, so I'm going to solve for it by dividing by 2. It looks like b is equal to 6. Now let's move on to triangles. You're probably familiar with the formula for area of a triangle as well. It is just base times height times half, or you can think about it as base times height divided by 2. It's the same thing. Dividing by 2 and multiplying by half are the same thing. Okay, so now let's just try to make this formula make a little bit more sense intuitively. Okay, let's draw out a parallelogram, a nice rectangle here. Okay, and we know that the formula for a parallelogram is just base times height. But if we notice here, if I were to cut this thing in half, I'm left with 2 triangles. So if I do base times height times half, I'm only left with the area of this triangle. So that's why it kind of makes sense that area is equal to a parallelogram cut in half. Okay, and again, just kind of going through the height, you got to be a little bit careful with height with triangles. Sometimes you'll have the height given to you in the middle here like this. Otherwise, if we have kind of a crazy obtuse triangle like this, the height would be written off to the side like this, the dashed line. This would be the height here, okay? So let's look at some examples here. We need to find the area for this triangle here. Remember, this is not the height, okay? We're going to do base times height and then divided by 2. So it's just 6 times 4.7 times 1/2. And that will get you 14.1 yards squared. Okay, we got another couple examples here. So our base for this one is 7 and our height is 5.4. If you're having trouble figuring out which side length is your base, if you have the dashed line in the middle of the figure like we do here, the base is always going to be the side length of where that line is coming out of. Okay, so for this one we got 7 times 5.4 times 1/2, which equals 18.9, and this is in meters, so this is going to be meters squared. Remember, area problems, you need to have that labeled correctly with units squared. All right, this last one, we have another example where we're given the area, but we're missing a piece of information. In this case, it would be the height, okay? So let's write the formula down here. Area is equal to 1/2 times base times height, all right? And we know the area is 35, so we're going to plug that in for the A, and we know the base is 11.3. Okay, so let's go ahead and substitute out those numbers. We have 35 is equal to 1/2 times 11.3 times the height. All right, and now we can just solve this out. Let's multiply 1/2 by 11.3, and that is 5.65. And now we want to get h by itself, so we're going to divide both sides by 5.65. And I'm left with the height is equal to 6.19, and this is going to be meters. So this is 6.19 meters. This is not squared because this is not the area, it's just the height. All right, hopefully you didn't think this unit was going to be that easy. We are going to have to use some of our knowledge from some of the previous units to find some missing information, and then we can find the area. Okay, so the first thing we have here is special right triangles. Due to this kind of craziness of this year, we did have to skip this unit, but that's okay because we can use trig functions for anything, for any problem that you could use special right triangles for as well. Okay, so for this unit, you will need to remember Pythagorean theorem, and you will need to be able to use trig functions to find missing side lengths. All right, so let's take a look here. This first problem, we need base and height, and we don't have either, right? This would be our base, this would be our height. So we need to figure out what those lengths are. So let's see, this is the angle that we're going to label our sides in terms of. This is our hypotenuse across from the right angle, right? The side length that is across from the angle, not touching it, that's the opposite. And the side that is next to, but not the hypotenuse, is the adjacent side. Okay, so why don't we try to figure out our base first? So that would be x. So if I were to try to figure out this side length, I would need to use sine because I have the hypotenuse and I need to find the opposite. So I'm going to do the sine of 60 is equal to x over 10, because it's O over H, right? And I solve this by multiplying by 10 because the number is in the denominator, so this will cancel out. And if I do it to one side, I need to do it to the other side, so I multiply 10 times the sine of 60, which equals 8.7. All right, so there is our height, right? 8.7, or sorry, that is our base, and now we need to figure out our height. So now I'm looking at AH, so I need to use cosine. So the cosine of 60 is equal to A over H, so this is x over 10. So we're going to solve this one the same way, multiply it by 10 on both sides, and I'm left with x is equal to 5. All right, so there we go. Now I do have my height. So now I can plug it into the formula, base times height times half. And what do we get? So that's going to be 5 times 8.7 times 1/2. And I get 21.75. And this is area, so we need to label it meters squared. All right, this next problem, we've got a parallelogram. So let's see, what do we need to find here? We have our base times height, and we are not given our height, so we are going to have to figure that out. Let's first look at our base. Our base is made up of this 15 and 5, so our base is 20 here, okay? And our height, we have 2 side lengths, so let's go ahead and use Pythagorean theorem because it's a right triangle. Let's remember that our C has to be the hypotenuse, or hypotenuse is always across from the right angle, so in this case it's 13. So scooch this down so I have some room to write. We're going to be left with C squared, 13 squared, is equal to x squared plus 5 squared. All right, so now we square them out. 13 times 13 is 169. 5 times 5 is 25. All right, so now I want to isolate the x squared, so I need to get rid of this 25. We do so by subtracting on both sides. And I'm left with 144 is equal to x squared. And now I do the inverse operation of squaring, and I take the square root. I'm left with x on the right side and 12 on the left side. So there you go. There's my height. My height is 12, and my base is 20. So we're just going to do base times height, which is going to be 240 meters squared. All right, now let's look at this last example here. We have our height, but we don't have our base. So we have a missing side. All right, now let's look at this last triangle here. We have our height, but we don't have our base. Okay, so if I'm given one side length and the angle, I can use trig functions to figure that out. So let's go ahead and label our sides here. Across from the right angle is our hypotenuse. Across from the angle, the side that's not touching the angle, is our opposite. And the side that is touching the angle, right, it's next to it, but it's not the hypotenuse, is the adjacent. So for this one here, we don't really need to know anything about our hypotenuse, so we need to solve for our adjacent side. So we'll put our x there. So it looks like we're left with O and A. Which ratio uses O and A? That would be TOA, tangent. So we're going to do the tangent of 61 is equal to 19 over x. And this one's different from the other one. We have the variable in the denominator. So what we're going to do is just switch that out. Okay, going to be x is equal to 19 over the tangent of 61. Plug that into your calculator and we get 10.53. Okay, so remember with these problems, we are solving for the area, so we're not done yet. So far, base is 10.3. We still need to plug it into the formula. So now we're going to do 19 times 10.3 times 1/2. Sorry, 19 times 10.53 times 1/2, and we're left with 100.035. Let's just call that 100. And let's see, we don't have any units here, but we still need to make sure we label this, so let's just call it units squared. All right, I got one more problem for you guys today, but it looks like it's going to be pretty challenging. All right, so looks like we need to solve for x here. And let's say the area is equal to 16. All right, so if that's the case, let's look at our formula. Area is equal to base times height. And we know our area, and we know something with our base and height, right? So let's go ahead and substitute out 16 for A and what we know for our base and height. So our base would be x plus 2, and our height would be x minus 4. Okay, so we can still multiply these binomials out. We just have to do a bit of foiling. So we're going to do x times x, which is x squared, and x times negative 4, that's negative 4x. We're going to go to the 2, so we're going to go 2 times x, that's 2x. 2 times negative 4, that's negative 8. All right, and this is all equal to 16. So now let's see, we can combine like terms on the right side. So we're left with 16 is equal to x squared minus 2x minus 8. All right, and if I want to solve for x here, I need to set this thing equal to 0. Okay, so this is kind of a step that a lot of people forget. Okay, we need to set the equation equal to 0. All right, and we do so by getting one side equal to 0. So I have 16 on the one side, so I'm going to subtract 16 over here, and if I do it to one side, I need to do it to the other side. All right, so now I'm left with 0 is equal to x squared minus 2x minus 24. Okay, now I can factor out the x. So let's see. We're looking for the two numbers that multiply to equal negative 24 and add up to negative 2. So what we do is we look at the ways that we can multiply 24. So we can do 24 times 1, 12 times 2, 8 times 3, and 6 times 4. So these are the four ways that we can multiply that out. And then which set of number or which pair here could also add up to negative 2 by manipulating the signs. All right, I think that is going to be 6 and 4. So if the 6 is negative and the 4 is positive, that will fit both criteria. They'll multiply to negative 24, but they will add to negative 2. So we're going to start this out. We know it's going to be x in the first parts of each of these brackets because our first answer is x squared, okay? And it's going to be negative 6 plus 4. Okay, so what we have here is basically two different equations. 0 is equal to x minus 6, and 0 is equal to x plus 4. So what would our values of x be? All we have to do is solve our equations. What number minus 6 equals 0? Well, that would be positive 6. If you're not sure here, you can just isolate the variable just like we normally would, and we're left with 6 is equal to x. And for this one, we want to isolate the x by subtracting 4 on both sides. So I'm left with x is equal to negative 4. Okay, so for this example here, technically negative 4 would not really work because for this one, it would be negative 4 minus 4, which would be a negative number, and that really wouldn't work. So positive 6 is the only answer, but I'd like to get both answers from you for the practice problems. All right, hopefully that made sense. If you do need help with these problems, definitely come see me or meet me on the Google Meet. All right, good luck.